Good afternoon, everybody. Thank you for coming for this session, Establishing a Data Parameter on AWS. So in the next 30 minutes, you will learn how to establish organizational-wide guardrails to help prevent unintended access to your data. So my name is Edmund. I'm an associate security architect that helps our customers to build securely and confidently on AWS. So joining me on stage later will be Zhiwei, who is a financial services solution architect. So for today's session, this is what we will cover. What is data parameter? Why should you implement a data parameter in your environment? As well as how do we go about implementing one? So let's just get started. So when we want to talk about data parameter, we first want to look at what is data access management on AWS. We are familiar with the principle of least privilege, which is giving your users only the necessary privileges for them to complete their tasks. So in AWS, we see least privilege as a journey where you first give your teams a set of access to cover their potential operational needs. And then you verify and refine the permissions when your workload actually matures on AWS. So these fine-grained permissions are usually set on your IAM users and roles. And sometimes this can be configured on resources as well. Data parameter, on the other hand, uses coarse-grained controls, which allows you to set a boundary around your organization that your teams will actually operate in. So this can be done by enforcing organizational-wide rules that shouldn't be subverted intentionally or not by anyone that is operating on your corporate AWS accounts. So we will cover examples in greater detail later on how this will exactly work. So what exactly is data parameter? So data parameter is a set of preventive guardrails in your AWS environment that helps you to ensure that only trusted identities can access only trusted resources and from your expected networks. So this will vary based on your organization's security requirements and the data access needs that you might have. So data parameter hence will allow you to establish a boundary around your corporate data center and everything within them, so identities, resources, as well as the networks. So this will form the trusted parameter. Everything else, non-corporate AWS accounts and the rest of the internet will actually be considered untrusted and shouldn't have access unless you provide the explicit exception to them. Okay, so when we start implementing data parameter, we first want to define these three terms that you are seeing on the screen. So that being trusted identities, which usually encompass IAM principles within your AWS environment. So that will be your corporate accounts. Trusted resources, which will include resources in these AWS corporate accounts. So for example, your S3 databases, as well as the instances that you are using to store or process your data. And finally, expected networks will normally include your on-prem IP space, corporate IP spaces, and the AWS network. So as you can see on the screen, these definitions wouldn't be completed without considering scenarios where AWS services are acting on your behalf. So an example of such a scenario is AWS config, assuming a role that you assign to it to write to your S3 bucket. So in those cases, AWS services may be using the role that their own principals to access your resources, or they may be using your principal to access the resources, but from AWS network. So you will normally extend the definition of trusted and expected to also include something that is under the control of AWS services. So knowing the three terms of a data parameter, we want to know what are some of the tools that you can actually put in place to actually implement one. So there are three policy types that you'll be using to implement a data parameter control. So the first one being service control policies, so SCP. That is an organizational policy that allows you to establish the maximum permissions available to your users. And you can actually apply a SCP on an account level, organizational unit level, or a root level. So the next one being VPC endpoint policies. So those are actually policies that you can attach to a VPC endpoint. That will further restrict the access that is allowed through those endpoints based on your security requirement. And lastly, on the resource-based policies, so there are ones that you actually attach to your resources so that you can actually control the access into your resources. Okay, so Moving on, considering those tools and definitions of a data parameter, we will define 6 different security objectives within the data parameter framework and divide them into 3 different parameter types. So I would like you to notice that in each parameter, we will implement 2 of the 3 policy tools that I have mentioned in the previous slide. So now, what are these parameters trying to achieve in your environment? So the identity parameter is trying to establish who is making the call. So with the intent to make sure that only trusted identities can access resources and from your network. Resource policy is trying to establish what is being accessed. So with an objective to ensure that only your trusted resources can be accessed by your identities and from your networks. Lastly, on the network parameter, that is trying to establish where the request is actually coming from. So network parameter controls help to ensure that your users and applications' credentials cannot be used from networks which are not managed by your organization. So after knowing the control objectives in each of the parameter, we will now look at why you should implement data parameter in your environment. So identity parameter actually helps you to prevent untrusted identities from accessing your resources and from operating in your network. While resource parameter prevents your identities from using or accessing untrusted resources. And the network parameter actually protects your resources even when your credentials are taken outside of your network. So while establishing a data parameter, you will see that the policy type that you'll be using will actually be depending on the specific security objective that you want to implement and where you'll be implementing the control and which of the resource you would like to secure. So until now, you have learned the main definitions within the data parameter framework. We also look at the security objectives and policy types that can be used. So now the question is, how do you actually codify these definitions and security objectives into an IAM policy language? So before that, we want to just take a step back and think of some of the scenarios. So how many of you in the audience right now are actually worried that your teams will accidentally grant access to someone that is outside of your organization or having a public access for your resources? Yep, I see one hand there. Yeah, so the trusted data path here, right, is your corporate credentials being used to access resources within your organizations. So these are actually IAM roles that your users can use to access resources like your S3 bucket within your accounts. So all the access pattern paths that you are seeing on the screen right now in green, they are trusted access path. So it can be an access path to your own corporate AWS account or even a cross-account kind of like access, but within the same corporate organization. So what you want to deny here is the use of non-corporate credentials to access your resources. So those could be like identities from other non-corporate AWS accounts or even unauthenticated access from somewhere in the internet. So I mentioned at the start that we need to take into account AWS services that are actually acting on our behalf. So the example given here is when you configure CloudTrail to continuously publish your account logs to one of your S3 bucket. So CloudTrail actually uses a service principal to make that call to S3 service. So that service principal doesn't belong to your account, but rather it belongs to the CloudTrail service account. So you need to permit that access through your parameter if you are using such a service. Okay, so we move on to look at how identity parameter can actually be implemented on a resource-based policy. So when it comes to codifying the resource-based policy, in order to differentiate between principals that belong to your organization and those that don't, you use the principal or ID condition key to specify the identifier of your AWS organization. And now, in order to permit the service principals into your parameter, you use the principal is AWS service condition key. So that key is set to true when the AWS service makes a direct call to your resource using the service principal. So how should we be reading the policy? So from the top to the bottom, this policy has an effect of deny on the S3 actions stated on the S3 buckets with the name of my data bucket when the condition of principal or ID does not equal to your organization ID. and the flag of principal is AWS service being set to false. So as you can see, we are applying fine-grained access controls to limit the actions and resources. And also, we are using a coarse-grained control through the condition keys. So you are seeing data parameter and your IAM granular controls working together. So on to the next scenario on the identity parameter. So just a quick thinking on your part, are you actually concerned about your developers bringing their personal account credentials into your network, and they try to transfer data that resides in your corporate network to a personal S3 bucket? So I think there are some nods in the crowd, right? So when it comes to the use of your network, your trusted data access pattern is that your corporate credentials being used from within your network to actually access your resources within your corporate AWS organization. So this could be accessing S3 bucket similar to the previous scenario through your own AWS corporate account or cross-account access. Okay? So what you want to prevent is the presence of non-corporate credentials in your network, because that represents a risk of potential data exfiltration. And when you implement controls to prevent such a data access pattern, you still need to account for scenarios where AWS services, like CloudFormation, access AWS own resources from within your network, not using your corporate credentials, but through a service principal. So to codify these assertions, we will implement VPC endpoint policy since we are protecting your network. So this will ensure that only your trusted identities can be used from your network. So similar to the previous objective, you'll be using principal or ID to differentiate between corporate and non-corporate credentials in your network. And likewise, to permit the service principals to be in your parameter, you can use the principal is AWS service condition key to allow AWS service to make a direct call from your resource using the service principal. So we have spoken about how we can implement controls on the identity parameter. Now we'll move on to how this can be done on the resource parameter. So just a recap, resource parameter allows you to ensure that your trusted resources can only be accessed by your identities, and they can only be accessed from your network. So one more scenario. So how many of you are actually worried that your developers are accessing resources that do not belong to your organization? Yay, more hands. With this parameter, you need to ensure that your corporate credentials can be used to access resources that you own. So as you can see, that corporate credentials can be used to access S3 buckets, whether it is cross-account or accessing your own S3 bucket within your corporate accounts. So there are two scenarios that you would like to prevent here. There is one, your corporate credentials from being used to access resources that do not belong to your corporate AWS account. And two, your corporate credentials from being used outside of your network to access the resources that do not belong to your corporate account. So just keep in mind that in certain cases, your corporate credentials will need to grant access to AWS own resources as well. So for example, when you are using AWS Systems Manager patching capability, SSM agent will be running on your EC2 instances, and they will actually make unauthenticated calls to your AWS own S3 buckets to fetch the patching baseline. So you need to account for such a access pattern when implementing resource parameter controls. So to manage your resource parameter, we will be looking at implementing a service control policy as well as a VPC endpoint policy. So when you start building your service control policies, the primary condition key that you are looking here is the resource org ID. So resource org ID allows you to compare the identifier of the AWS organization to which the requested resources belongs with the identifier that you actually specify in your policy. So in this case, we actually create a SCP with the key condition of the resource org ID of the value of your organization ID. So this SCP has an effect of deny that will actually block any access that does not have the resource org ID. Okay? So to protect your network, now we will know that we will put in place a VPC endpoint policy. So the condition keys that we are looking here is as well principal or ID and resource or ID to ensure that identities are actually coming from your network organization. To allow the service principals to be within your parameter, we will then use the principal is AWS service condition key to allow AWS service to make a direct call to your resource using the principal. And in order to allow access to AWS own resources, you can list the Amazon resource names, ARNs, in your policy as well. So we have looked at the identity parameter as well as the resource parameter. So now I'll hand over the time to Zhiwei, who will actually talk about how can we enforce a network parameter in your environment, and as well as what are some of the key takeaways from today's session.
All right, thanks, Edmund. All right, thanks, Edmund, for going through identity parameter and resource parameter. So now, time for the final and most exciting parameter control, and that is network parameter. Network parameter is the parameter that allows us to ensure that your resources and identities can only be accessed and used from expected networks. So how do we define expected networks? Expected networks will include your corporate data centers and your AWS VPCs, but not a random coffee shop. With the pandemic, there's a new access patterns where your employees work from home and they connect via VPN to your corporate data centers and access AWS resources from there. Here, on this slide, you can see direct access by your identities to your AWS resources. And this is the specific access patterns that you would like to protect the most, because there's humans here involved, and they can actually take your corporate credentials and bring it anywhere else. So how do we codify the definition of expected network in an IAM policy? So this is an example of a resource-based policy. In this bucket policy, you'll be using two primary condition keys. One, source IP, and two, source VPC. Source IP is to allow you to specify your corporate IP address range, and source VPC is to specify the IDs of the VPCs that belong specifically to your organization. If your organizations are using VPC endpoints, you can use the condition key source VPCE to specify the individual endpoints, or you can still use source VPC to specify the VPCs that the endpoints are being deployed into. So when implementing network perimeter controls, other than specifying the expected networks, you also have to take into account AWS services that are acting on your behalf to access your resources, but from outside your network. So there are four main types of access patterns. First would be AWS services using the credentials of the principal that is making the original call to then make subsequent calls to other AWS services. So on this slide, you can see, for instance, you can have an application running in the VPC, creating and running Athena queries. Athena then takes the application credentials to then access your S3 buckets to get the data and then return the results to your application. So this call from Athena to S3 does not come from your network. It comes from Athena Service Account Network. Next, remember the CloudTrail example that Edmund has gone through earlier? When CloudTrail is actually publishing logs to your S3 bucket, it's using service principal. And this service principal, the call from the service principal to your S3 bucket to push the logs there, also does not come from your network. It comes from CloudTrail Service Account Network. Third, there are services that use service link roles, SLRs, to access your resources from within their own networks. So, for example, IAM Access Analyzer uses a SLR to then access your IAM policies that's in your AWS environment and then return to produce its findings. So what is SLR? SLR is a special type of role that is linked to a specific AWS service and that AWS service actually predefines the permissions associated to that role. So now for the last access pattern, AWS service role. So AWS service role is used by AWS service to act on your behalf, and unlike SLRs, AWS service role is not an SLR. They don't have fixed naming conventions. they don't have predefined permissions. You can attach any permissions you want to a service role, and they can be further restricted by service control policies. So in this example over here, we have Amazon Comprehend using a service role to perform analysis jobs in the documents stored in your S3 buckets to produce its findings. So you may be wondering, like right now, like how do we codify and create all these 4 exceptions in our IAM policy, right? So moving on. Building upon the same bucket policy that we have went through earlier, this is the same example where we actually define the expected networks. And so let us try to add in the exception that I went through slightly earlier. First, we have via AWS service condition key, will take care of AWS services that are using caller's credentials, for example, like Athena earlier. Next, principal is AWS condition key will account for AWS principles or service principles like CloudTrail service principles. Thirdly, as mentioned earlier, since service link roles, SLR has a fixed prefix, if you notice, /AWS-service-role, we can use principal is ARN condition key to account and create exceptions for such roles. Finally, for service roles, you can use tagging to actually include them and create exceptions within your network perimeter on resource-based policy. So we can see that when implementing network perimeter on a resource-based policy, this may become a little bit challenging, especially when you adopt a variety of AWS service. But however, not to worry, you can always choose to target your identities first because it represents the highest risk. So how do we target identities? We'll be using service control policies. So this is an example of a service control policy that you can use to implement for your network perimeter. It shares many similarities with your resource-based policies where you have source IP to restrict based on your corporate IP address range, source VPC to restrict based on the VPCs that belong to your organization. And same as before, we are also using via AWS service condition key to account for AWS services that uses caller's identity. And one thing I'd like to highlight is that since SCP acts as a guardrail on your organization level, it applies to all your organization identities all at once. So to prevent this thing from happening, like you don't want to implement immediately, you can actually use tagging to gradually include identities that will be affected by the service control policies. So in this way, you can gradually implement the network perimeter controls of course, in your own risk-based approach to security. And finally, notice that there are much fewer exceptions in service control policies as it only applies to identities that belong to your organizations. It's easier to implement network perimeter controls with service control policy because SLRs and service principles, they are AWS identities and are not affected by service control policies. So putting it all together, this table actually summarizes all the concepts and capabilities that we have discussed so far. And the key point to take away here is that there are many primary condition keys, such as principal auth ID, resource auth ID, source VPC, source IP, that allows you to restrict access based on your organization and location of your identities, resources, and networks. There are also condition keys like principal is AWS service, and via AWS service that can help you to extend your perimeter to include AWS services that are acting on your behalf. So although you see that there are 6 controls, it's important to note that you do not need to implement them all at once. Some consideration to take note would be the scalability to enforce identity and network perimeter using resource-based policy. Does your organization have a pipeline to automate the deployment of each resource-based policy, or is every single resource-based policy handcrafted? Another consideration would be, will it break other services that you have currently in your environment when you're implementing such controls? So our recommendation here is to go by a risk-based approach. Start slow, implement one control at a time to gradually reduce the risk. So I hope that we have gotten everyone's interest in establishing a data perimeter in your AWS environment. So here are some tips that you can follow when you're doing so. First, do a review on all your existing access patterns that may be impacted when you implement a specific control. You can use CloudTrail with Athena, or you can use CloudTrail with CloudWatch Logs Insights to query and view historical data access patterns. So you want to ensure that you have included all valid access patterns in your policies that you are building. Next, communicate to your end users. Please inform your end users when you're going to implement a specific control and how it might impact them, so that they can let you know if they have experienced any errors. Thirdly, monitor for errors after you implement the controls. Look out for spikes in access denied errors using the same tools that you have used when you are doing the reviewing of access patterns. Because you may need to roll back if necessary for readjustments. Like for example, if you miss out an exception that you thought that you have included. And the final tip that we have for you is actually a generic best practice to test in a non-production environment first, and once you're comfortable, proceed on with the production environment with the same steps. So finally, the key takeaways for the entire presentation. It's important to note that data perimeter is a form of coarse-grained control to protect your organization as a whole. It sits above and beyond your existing IAM users and roles which have fine-grained permissions, and ensures that your trusted identities can only access trusted resources only from expected networks. There are 6 types of controls and 3 main policies that you can use to implement them. An easy way to remember would be to use this triangle on the right of the screen. To implement an identity perimeter, cover trusted identities, and you're left with resources and networks to implement your controls on. To implement a network perimeter, cover expected networks, and you're left with identities and resources to implement your controls on. And as we have mentioned earlier, you can use service control policy to manage your identity, VPC endpoints for networks, resource-based policy, of course, for resources. So there are multiple controls and they are pretty much independent of each other. This means that, of course, as mentioned earlier, you do not need to implement them all at once. And we have seen customers doing it in phases, gradually enabling it in their environment based on their own risk-based approach to security. And lastly, remember to test implementing your controls in a non-production environment, monitor for errors, communicate to your end users before you move over to a production environment. And that's all we have for you today. So, to build your cloud skills in AWS, please visit AWS Skills Builders for all our digital courses and hands-on labs. They are available for you to learn at your own pace. So thank you so much for attending our session, Establishing a Data Perimeter on AWS. Please do take the time to fill the session survey and let us know what you think. Thank you.